Please.
Yeah, thank you, Rohita, for accepting our invitation and then starting the lecture series. Good afternoon, everyone. I'm Dirina Hettiarachi from CSEC. Engineer Rohita Silva was very kind enough to offer this opportunity. I believe this is a once in a lifetime opportunity because you always get to learn about structures. You rarely get an opportunity to learn about bridges. So it's a fascination for most of the structural engineers, I think, to learn about bridges because that's a black box that we hardly know anything about. So I'll give a brief introduction to Engineer Rohita, who has a very vibrant and a vast career for over 25 years. And he has worked in overseas, both Australia and Thailand. Engineer Rohita has graduated from University of Monato in 1991, and he has obtained his master's from AIT in 1994. He has worked with SMEC Sydney, and then he has been the principal bridge designer there. And then from 1994 to 1998, he has worked at Unique Engineering and Construction Public Corporation Limited as well. Right now, he's working with Becca. And as I got to know from most of his colleagues, he's one of the best teachers that they have ever got. So I think we have got a great opportunity to learn from a brilliant engineer and a teacher as well, because I was told that his teaching capabilities so that all the students were very keen to learn from him those days. And I'm sure even today it's the same thing. So I won't take much time because if I go on talk about Engineer Rohita, it will take a long time for me to complete it because he has such a vast amount of experience and the qualifications. I will stop from here and leave the this to you, Rohita. You can start. This is a lecture series, by the way. This is only the start. So I hope all of you will join us throughout this series and get the maximum out of it. Thank you so much.
Yeah. Good afternoon, everyone, and good evening from Sydney in here. I would like to thank Dilina and CESC for organizing. Dilina worked really hard to get this one organized within such a short period of time. Even he's forgetting about his health. And then my good friend Shiromal is, when I was having a chat with him, he said, yeah, that's a great thing. This has been planning a long time ago, but yeah, somehow the other, the CSEC, I'm sorry to CSEC, I think they were kind enough to organize this presentation series. And I am Rohit Silva, and I know around the world we all are having a really hard time because of the pandemic. It's all same back in Sydney. Yeah, same situation in Sri Lanka as well. But the good news for you, you all, is that I think you got your freedom day today. I think that's what I heard in the news. But still, we are in the lockdown, working from home. You can see in my background, I'm not really good at all these things. You can see in my background, in my home, in the living room. This my cabinet is in here. So let's get into the discussion now, because I thought of doing a bridge design series. In the sense, bridge design you can't learn within a day, or you can't teach within a day. So we're going to do a few sessions to cover that one. I will go through that one later. Today in the session one, it's kind of an introductory session. I put the name Design and Construction of Modern Highway Infrastructure in Australian Perspective. Then this is an introduction about myself. And then I just want to put this disclaimer. This is the way I always do my presentation. The disclaimer informs the audience that the view, thoughts, and opinion expressed in the presentation belong slowly to the presentation. It's me and not necessarily to the presenters past or present, employers or any organizations or any individuals. The information in this presentation document should not be used for comparison, evaluation of others' work or against any individuals or organizations. This document should not be should be used only for educational purpose, not for commercial purposes. The sole intent of this presentation is to share presenters' engineering experience with future generation of engineers and use them for the betterment of engineering and well-being of society. That's the this disclaimer. And I just add a bit of my own thoughts to this presentation. This is my own writing. This is the where we're going to start. I thought it's better to start like this. If a knowledge of a bridge engineering is like a country, what you are going to see in this presentation series is like exploring a small place in a village. Therefore, it is your responsibility to explore the country, the knowledge, to further enhance your enthusiasm to understand the beauty of the country, passion to learn bridge engineering, and to be a confident explorer, a bridge engineer. This is the way I looked at, this is the way I built up my career. And so then I'm going to discuss with you quickly the presentation format. As I mentioned before, I can teach you bridge engineering, but for you to understand how is it, the beauty of it and how you're going to apply it in actual applications in the design office and in the field, you need to understand a bit more. Therefore, I divided into a couple of sections. The first session, session 1, is the introductory session. We discuss about key element like a jigsaw. In a jigsaw puzzle, all these jigsaws in the elements we're going to discuss today. And the session 2, I'm going to go to a bridge element and performance, because before you design anything, you should know what it is and then how they're going to perform. If you understand that one, then the rest is much easier. Then the session 3, I'm going to discuss with the bridge, the design principles. What are the engineering principle? As you all are structural engineers, you know the limit states principle. In addition to that, in bridge engineering, what are the other aspects we're going to see? And then we're going to discuss about the bridge loading and application. I can hear someone speaking here in background. And bridge loading and application. Then what are the type of loads in the bridge? How are we going to use them in the design? How to combine them? How to understand them? Yeah, and then the bridge articulation and application. The bridge articulation, what is the bridge articulation? The movement of the bridge. Why we are having expansion, join and bearing and etc. And what is the purpose? How are we going to understand them? Then I'm going to talk about when you understand these 2, 3, 4, 5 sessions, you get a better picture about what is a bridge looks like, how is going to behave this bridge. Then I will teach you how to do a bridge modeling. All the structural engineers, we do structural modeling. So then we can understand how we can model a bridge and how to, in the different bridge, different applications. Then I will take you to bridge design in next 2 sessions. Bridge design is really vast. You're going to learn that one little later, but I will try to use in the 2 sessions to give you as much as input for you to, when you are designing a bridge, to design them. Then this is something I always say, session number 9, because if you get engineers, we got a minimum bachelor's degree. Some of them, most of them got PhDs. And then we have experience from 3 to 4 years to 30, 40 years. Whatever we design and we do, at the end of the day, we all need to understand as an engineer. This is always I'm telling to my engineers and others. everything is going to build in the site. Most of the people, key people in the site, they hardly pass grade 10. Yeah, most of them, they hardly get to the grade 10 in high school. So they are the people is going to build them. Then your knowledge, your thinking, your modeling, your analysis, everything you need to translate into set of drawings that everyone, that layman kind of that level of people to understand. Therefore, bridge drawing is the most important and key element in bridge engineering. Another thing, when you come to costing and pricing, the bridge drawing is play a significant role. It deal with contracts and other things. You will learn over the when we go to the session. Number 10, I'm going to speak to you about reporting and specification. The reporting is the one of the really big part. We need to improve ourselves as an engineers, the reporting and specification. Then the section 11, I will take you to SID. SID means safety in design. And value engineering, constructability, I mean independent verification, PE mean proof engineering. What are those elements? How are we going to use them to get the better value out of our design and projects? The reason I'm talking about these things, SID is very important, safety of the people when they were building and when they were using it, when they were maintaining it. So as a designers, and then how we going to incorporate them into our designs. And then in the section 12, I'm going to summarize the section 1 to 11, and then I'm going to have a discussion session with you. Then I add the number 13, 14, 15. In a highway infrastructure, not only the bridge, you will come across with tunnels. If you are designing a tunnel, how do you do it? What are the main elements in there? How to understand them? What are the functional requirements and how you assemble them? Because I was lucky enough to stay and work in one of the best tunneling project in Sydney. So I would like to share that my knowledge with you. And then I want to share with the fire design as well. This is quite important when you are designing, especially tunnels and sometimes the buildings. And then I'm going to introduce you to the rail bridge design. It's more or less similar to the highway, the bridges design, but it's a bit different. What is the difference? How we're going to use our knowledge we learned from the previous sessions. I think the reason I put this one in here, just please forgive with me because I didn't set the date. The dates I will set and I will send to Dilina. I think Dilina will be give it to you. I think because all these sessions, sometimes if you are not interested about the bridge modeling kind of a thing, you are more interested about the workshops, reporting, specifications. So then you can jump into those sessions. Yeah, whatever your interest. But it's better if you just participate, even if you are not going to design the bridges, but this understanding is going to help you. The learning I got over the 25 plus years of my postgraduate, then I just want to share with you. I'm not going to keep anything with me. Just I want to give everything to you. So it's up to you to understand. And before I get into the session 1, I want to let you know, because this is a session because we all are professional engineers, and we can make like a conversation. This is a live streaming because I am in Sydney, you are in Colombo, and different part of in Sri Lanka, or some part in New South Wales. So when we were when I'm asking some questions, maybe like maybe you can raise the hand, or you can send a message. So then in the chat room, then I can answer to that one. The today presentation, the way I structured, I just give you a difference between a building and bridges. I'm not going to talk about this one in length, but just to, because most of you involved in the building design, so I just want to get your head out of that one, and just to, yeah, give you few examples, what is the difference. Then I will talk about the objectives in a highway infrastructure project, then the issues we are facing. And highway infrastructure projects, we have a value-added things like aesthetics. Then I'm going to run a video. This is one of the project I involved. This is the RMS project. I'm going to play that video for you to see if the highway project, what are the elements involved in there, and the things around that one for you to visualize better. Then I'm going to explain you the different type of bridges you're going to encounter. I mean, I listed few, but there are plenty. In addition to that, the highway infrastructure project, we always involved with retaining structures and other structures. Then we have a quick 5 minutes break. Then I'm going to focus about the durability of structures. This is really important. This is one of the key area today everyone is focusing. And then going to discuss brief about the safety in design. Then the latter part of the presentation, I'm going to discuss about the quality control and quality assurance, how we're going to make. And then lastly, the Q&A session. If you have any questions, so if you have any opinions, so then we can discuss. Any question up to now? At least someone need to, yeah, just at least Dilina, you had to, yeah, say yes or no, because because it's a bit different because I'm just talking to a computer.
Yeah, it's very
yeah.
I can understand. Yeah.
All right, guys, then there is no questions, then I will proceed here with, okay. The difference between the building and bridges. I know, I think everyone, most of you know what is this building, right? It's designed by CSEC, and it's one of the beautiful building in Colombo. And this is a building you can see on your top right-hand corner. There's a bridge. If you go to Bangkok, if you stand up in the Bayok Tower, if you look at this one, this is the bridge you're going to see. Yeah. The reason I put this picture, that our bridges go under, go top, it's got a really different shapes. If you see a difference between the building and bridges, the building go vertically up. Bridges do all these spaghetti things, right? You can see I put a picture, the family picture here, right? So we design our building for our families and for our communities to have a happy life in there, right? Then I have another picture, family with a car, right? This family, if they want to go on a picnic and a holiday, so they need to use the bridges, right? And again, I put this family, if you look at them, this family, the total weight, if you compare, is about 200 kilograms. Compared to when you are designing a bridge, you had to put this monster on your bridge structure. This is 70,000 kilograms. This is, I'm just talking about the gross weight. Then one thing quite common when you come to bridges and buildings go up vertically up, bridges go in horizontal directions, right? But still the bridges are beating the buildings because the building, the limits are still 800. They were experimenting 1 kilometer, but bridge already built more than 2 kilometers in span. Yeah. And both bridges and building we designed to serve our communities. Yeah, that's the common thing. And the other common thing, we engineers design and build it, right? But when you come to bridges, the loading and the environmental is going to face, the forces is going to impose on the structures, the locations we're going to build, all different to what we are going to go with building. Other main difference, it's very important to understand, the most of the building projects in these projects are owned by private sectors, right? So you are dealing with them, and the externally you are dealing with the government agencies. But most of the bridges, if you get highway infrastructure, at the end of the day is owned by government agencies, and it's built by public fund and taxpayers' money, basically. So there is a massive responsibility because the government agency has to deal with the people. It's very different the way you're going to deal with these two entities. You will see that one in the later. And another major difference in the bridge and the building is the design life of these structures. The current standards I'm talking about, we are designing buildings to 60 plus years. Of course, it will last more than 150, 200 years because they were solid concrete structures. The bridges we design to minimum 100-year design life. Some of the bridges we are designing for 120 years even. Yeah. Then this design life theme, I'm going to touch base with you because that's where I talk about durability. You will understand that one. That is one of the major difference in here. Why did I put this design life theme? Because for design bridges and for design buildings, we have two different codes. The major difference is the structural dynamics in a bridge and a building. There's significant difference in terms of the structural dynamics. These are one of the major differences you can identify, you can see when you are designing a bridge and designing a building. But your fundamental we use in both design is still the same. If you are a structural engineer, got experience designing building or any other structure, I'm sure you can design a bridge. It's not a problem at all. You trust me, you can have that confidence. If you attend all the sessions throughout, you can be, yeah, you can. Then I will jump into my presentation. The highway projects, going to talk about the objectives in highway projects. Why we are putting highway projects, very briefly. The first thing is to improve the road safety, reduce the accident, and improve the efficiency of the highway between two proposed destinations. So I think we all experience in Sri Lanka the highway between Colombo to Galle. You can see the amount of people going between these two cities. When we were growing up like kids, like when I want to visit my uncles in Galle, it's like a trip for us. But now it's different. Like you give a call to, if you have a relatives in there, you make a call and then say, I'm on the way to your place. Like I'm less than 1.5 hours away from your home. It's improve the efficiency and it's support the economic development. It's provide value for money overall and enhance potential economic benefits, manage adverse environmental impact and other things. And they optimize the benefits and adverse impact on the social and environment. These are the just listed few objectives when you are designing. You can list hundreds of thousands of them. Yeah, especially if you are the road development authority working for any road agencies. They have a list of so many objectives to fulfill, and then that's why we are spending millions of in terms of millions of dollars to build those infrastructure. So when we were building those infrastructure, there are many parties involved. The one is the client, is the owner of the asset, right? Road agencies. The other party is a designer. You design them. And another party, you own this, you want to build this highway. I can design this one, hands up someone. and then someone else say, I can build that one. So these three parties get together, and when they want to work together, so we need to have a legal document to bind three of us together, certain norms, certain standards, certain rules and regulation, put that one into there. That's why we need contracts. There are many contracts types, you can name it, but I just pick few. Design and construction contracts. The contractor just give a price. It's exactly same like you walk into a department store, you just buy a suit, right? Ready-made suit. Similar to that one. You have to pay a price, but you get a ready-made product. And the client will tell, I want to build in the highway infrastructure from point A to point B. And then this is my initial thoughts. This is the way I want that one. I need a 6-lane highway, 4-lane highway, and I need a couple of overpass bridges. And then I want to link these areas and together. And then the contractors and designers, they got together and they work out a design solution. And then the contractor will price how much going to cost that one. They are going to work in a piece of like a discussion, sometimes rough sketches, but it's cost you a couple of million dollars. Yeah. These contracts, you will later on understand, it's got a lot of risk involved. And the different client, they experiment these things in a different ways in different countries. It's very different. The construction to client design. The client will say, no, I think this DNC kind of a thing, I had a very bad experience before. I'm going to do, I will ask a designer and my our engineers from the road authority, the client engineers work together. They said, okay, we're going to do this design. And they will do the design and they prepare everything and give to client to price it. That's what I said, the design drawing and the specification and all other contract document, they're going to price it. Yeah, they will tell the construction, this is the cost. But while you are doing halfway through the construction, if a client changes mind, he just want to add something, he just want to cut something, then they need to realize that that's going to cost them a lot of money. The reason is that one, don't get me wrong, the cost is really high. Everyone need to understand when the contractor is in operation, the amount of money and the machineries and overheads he has to absorb during construction. So that's why it's changing easy, but it's going to cost a lot of money. The other one is the alliancing. The alliancing is the form of contract we use in a very high risk construction and design area. A lot of challenges, is many form of challenges. It may be construction, it may be environmental challenges, it may be safety related challenges, it may be brownfield or in a city area doing the construction, or you need to get a lot of people in board and get their input to get this project ongoing. Then we're going to alliance in kind of a contract. And the other one, public-private partnership, you can name it in different way. This one is like someone say, I'm going to invest for this project. I'm going to operate this one for 30 years. That's the general norm. And I'm going to operate this one. I'm going to charge if someone use the highway, and then that toll money. With that, I'm going to recover my investment. And then after 30 years, I'm going to hand over that one back to you. Yeah, these are the type of contracts. You can see the reason I put this thing in here. Now we're going to get when you are designing a bridge, when you're working in the environment, you have to think out of the box. It's not like a normal modeling and doing calculation in the office. Then I'm going to just brief a tendering process. This very brief. The whole process is happening. If you want to build the highway infrastructure from one place to another place, you have to plan it. You have to consult so many things. You have to acquire land. For example, if you're going to build something if you want to widen, for example, Gold Road from, you need to add additional 1 lane, let's say 1 left lane or right lane in a single section of the area. It's going to cost fortune. The main reason is not going the construction cost. You have to acquire the land. That's really costly. You have to pay for that. And then you do feasibility studies. You look at different alternatives to optimize the cost, get the best out of it. That's engineers we do almost every day. We try to get best out of everything to our communities. And then from that, we do attend the design, because the initial design is the alignment, for example, in the road, the number of lanes, the cross section dimensions. I need 4 lanes, 2 lanes inbound, 2 lanes outbound. These are my lanes. Then some places I just need a left lane to turn left. I need another right lane. I need a U-turn. I need traffic lights. All those things we incorporate in the tender design, but in a very basic level. And then you call your whatever the type of the contract you're going to deal with, and then you go to the detailed design. That is the real business you're going to do. Yeah. Then that is where you're going to get together. You can see in the next slide, you're going to produce the set of drawing that it would be able to build. Then the client, depending on the contract type, get involved with the contractor or consortium to build that particular infrastructure. When you build it, it's not going to end, because people are going to use it. As I mentioned, you're going to learn it later. All these structures has their own life, like us. And according to their performance requirement, their life is vary up and down. You're going to learn that one later. You will see in the slides. Then you have to maintain it. You have to keep running it. It's going to cost. This detailed design and this construction, both of these elements play a significant role. The performance of the structure, how it's going to behave, is going to cost so much money. Because the technology is developing so fast, every front in engineering, analysis, design, material, every front research and development, significant development around the world, that's make for us to have a better infrastructure each and every day. We can come up with better solution. Yeah, better solution. Therefore, we can get we can reduce our maintenance cost and other thing if we build and follow the right procedures. We can save a lot of money for our taxpayers, for our communities. This is the way if you're going to build a bridge. This is the stakeholders or the people you just need to get involved. Client is the key person, because he's the person who is going to pay for us. So we are sitting here, designers. We got a contractors here, right? And if you are a designer, if you design a bridge, it's not like you are just doing a simple modeling or something. It's very complex. You're going to learn that one later. You have to involve with a lot of people, like project managers. They manage the project. The people approve the project, verifiers. People look at the infrastructure, safety auditors. And if it is a highway, we always got alignment engineers. And we have to manage the traffic. We have to design the traffic. All this traffic modeling analysis, traffic engineers. We are riding on a surface, the pavement engineers. And we need during the construction, if you are depending on the place you're going to build, the staging engineers. And we are working in an environment, we have to preserve that one. We dealing with community. We need not engineers, but non-engineers, environmental and community people to deal with design stage, construction stage, to deal with the community, to make them understand this is what we're going to build. Because some people think they have a different views, and some people object to these projects. So we have to respect their opinion, and then we have to discuss with them. We have to make them understand why important this particular structure we're going to build in here. And we have to do a significant drainage and hydrology analysis. This is the area we really need to look at when we were designing a bridge. My simple explanation, when you are building a highway project from point A to point B, let's say that's a simple example, 4-kilometer highway. My simple definition is what you are going to do, you are going to put across the land 4-kilometer dam. 4-kilometer dam. This is my simple definition. And then drainage and hydrology engineers, they are the people manage that's not going to be acting like a dam. They will make sure once we build this one, this is not a dam. You can have a massive rain, but it's not going to flood one side and leave the other one. It's not going to build up the flood against our road highway infrastructure. Yeah. And then the water supply drainage designers, bridge, tunnel, civil designers, geotechnical engineers, they play a significant role in this design. And the durability engineers, they specialize in material engineering. Yeah, if you are a civil engineer with the interest, you can specialize in durability engineering. And they will tell you, as I mentioned, 100-year, 60-year, 20-year, 30-year design life, how we're going to achieve them, what sort of material we need to use, how we're going to maintain them, and they will let you know. Utility engineers, we have a lot of communication running parallel, and we need to support them for our infrastructure. In addition to that, we have to run them through our road corridors to serve the communities living around that areas. And then the urban designers and landscapers, I think that they play a vital role, because they will make sure your driving experience is memorable. I think you got a classic example recently. I think in Colombo, you see that Cablestay Bridge with very beautiful lights, right? Someone is asking why we need to light, because we don't have sometimes we get a power cut. That is not the purpose. That's the urban design and landscaping play a significant role, because you enjoy that one. Even you can stop your car in the side, and if you are tired, you can stop side by, you can just go and relax looking at that one. That's play a significant role, because they are playing a significant role in this infrastructure design. We are not engineers, we are engineers, not the structural engineers and geotechnical engineers do all this job. There are many engineers, many disciplines involved in this one to get this one delivered. And the noise engineers, fire engineers, civil and structural drafters, and all our builders, they all involved, they are stakeholders. If you go to contractors, they got their project managers, engineers, safety auditors, estimators, subcontractors, they got a special contractors. You will learn later on in the bridge engineering, there are specialist contractors, they do special bridge design. For example, launch bridge, segmental box girder bridges, that kind of bridges. And then the dock controllers, they play a vital role even in the designer side, the contractor side, because there are so many documents, so many interfacing, so many people involved. Today we are dealing in a digital world. We work through email all the time. So that's play a vital role. They play a vital role managing everything in the right, because people sending email every minute, every second, they have to manage that one. Now there are softwares available, there are systems available to make everyone life easy, but still they play a significant role. This is the stakeholders and key personnel. So yeah, just give them your brief outlook. If you design a bridge, this is where you just need to look at. The main reason of this slide is to let you know that you can't work in a box. You have to think out of the box. You have to walk around in your office. You have to talk to your friends. You have to smile with them. Yeah, say, talk to them, mate. I have this one. I have this issue. How do you look at that one? Rather than I am designing bridge, he is designing that one. You can't. There are lots of people inputs need for you to get that one to deliver. Yeah, you can see the client side. He needs to interface and manage this whole group of people all the time, from the tendering in the initial phase, in the planning phase, until it's delivered, then the maintenance phase. They have a significant role to play. Then I just identify few issues, because I'm talking about this, the Australian angle, the way when we design the highway infrastructure. Community and environment is one of the key issues we need to address. And I forgot to put this one, the sustainability. I think that is one of the key issues today. Well, I think most of you know, I think 2000, the WFEO, World Federation of Engineering Organization, they set target in 2030. We have to meet certain sustainable goals when we were designing infrastructure. These community issues, the flood, noise, vibration, when there is a flood, if there's cover, and sometimes if you build a bridge close to a port, because navigational requirement, if you interface rivers, creek, and some fisheries and thing, the post-disaster recovery, this is, I will touch base with you. Post-disaster recovery in the sense, let's say there's a massive flood event, there's an earthquake event, the natural disaster event. If happen, you are talking about, let's say, I will get example, your highway, the key highway is between Colombo and Goal. In that highway, if one of these bridge collapse or distorted, it's not safe for people to drive through, then this two link, you can't link the Colombo and Goal together, because that the 30-meter span bridge will impact that whole commute between these two cities. So then you can design your structure to because this is a minor investment at the beginning, though, you can design your bridge to recover post disaster recovery. You will learn when I'm discuss in the session 3, you will learn how we're going to quantify and identify, estimate, identify this environment in the design space, how we make this judgment. Yeah. Post disaster recovery, the simple mean, if the significant natural disaster event after that, still you can use your bridge. Yeah, we designed them, we can. And then the drainage and efflux is the very important, and the material usage. When we are using material, how we going to optimize, for example, when you are getting concrete, how much impurities like a fly ash, the other the material we can incorporate into our mix design and make that one better. So these things we need to address. Another thing, the heritage and the flora and fauna. The heritage is very important. Like when we were building infrastructure, sometimes we had to pass through heritage. So for example, sometime in Sri Lanka, there are events like if he has to get a highway, if there is a Bhutri or temple or any place people go to worship. So, and then if anything is value for our history, so then you can't just go and dig that one and take it out and leave it in another place and put your highway. They will say, okay, same thing, I'm putting this one here to there. No, we can't do that one. As engineers, we need to see how to solve that one, how to get the best outcome for the community, to the society. And the construction stage, it play a vital role, significant role when you are building a highway infrastructure. And the urban design, safety in design, the durability, and other thing. If I just touch base with the flood, I think you can set certain levels of limits when you control the flood in the design. For example, define the variation in the flood event current, and after you build your structure, we can control that one with the drainage engineers, they analyze, and they can flood control system they can put in place to make sure that the level difference is not going to go 300. So when we are sitting a bridge, we will build our bridge soffit level above 1 in 100-year event. You will learn the 100-year event, this very rare flood event, but still your bridge is not going to go underwater because you can still drive. That's related to the post recovery disaster. That's connect this one together. And the bridge is cover. When you build a bridge close to a creek, if there's a massive flood event, if your bridge is covered, sometimes the bridge is stand there, but you can use it because it is not stable to use it. Then you have to wait for months, sometimes years, to repair that one, let that one to function. These are the small thing, but they link together. You have to consider all these little things when you are a bridge engineer. You have to work side by side with your colleague to get the best outcome. And if you go to construction, the noise, construction noise during traffic, even the serviceable stage, it will make a really big noise, because when you put a highway, people are driving 100 kilometers per hour, 80 kilometers per hour, not the 1 or 2 cars you are expecting. You are expecting hundreds of thousands of cars every day throughout this design life. Because of that, I think the noise is a very important segment, yeah, when you are designing a highway infrastructure. Then aesthetics, yeah, the beauty of the bridges. You can see this. The first is called M7. You can see in the night how beautiful this one. This is a segmental box, the bridge they built. It's an interchange, right? You can see the one in the bottom is during the daytime, this architect, to make the shape of this bridge, the column, the pier in here, right? You can see the slopes they make. To make this bridge is matched with the surrounding environment and other aspects, like the certain the community aspects, the certain environmental aspects, all those things, he blend them together. He give you this shape. Okay, this one is difficult to design. You can easily replace this one as a rectangle one. It's very difficult to build, and it's going to cost you some money, extra money for client. Then they will say, hold on a second, we don't want to have this sort of column in here because it's expensive and it's here. But at the end of the day, this final outcome, when the people are driving, the feeling they get, this is blend with the environment, that is very important. So for that, you have to pay a certain price. Yeah. You can see the different forms. It's blend with the environment. The aesthetics play a very important role. And then I'm going to summarize up to now what I discussed with you, what I explained it to you in a simple, in a video. This video is about 7 minutes. It's in a World Wide Web. I'm going to play a video. Before I play this video, do you have any question? Dylan, anyone has any questions? So
looks like we don't.
okay.
We can move on. If there's anything, if they have put it in the chat, I will ask at the end of the session.
Okay, thank you. Yeah, just try to play this one. So hopefully this work. Sorry about this. You all can hear, right?
We can hear you. The video can't hear anything yet. We can't hear the video, Rohit.
Can't hear the video?
Can't hear. Maybe we'll have to increase the volume.
Yeah, I'll try to. Sorry. Yeah. Sorry, I think I'll open another. Can you see that?
Can't see yet.
And then, sorry, maybe I will play this one at the end. I think it's better.
Okay.
Yeah. Yeah. Sorry about that one. Yeah.
We can't hear Rohit. I think you're on mute.
Yeah. Okay. Yep. And can you see the slide now?
Yeah, now we can see and we can hear. Yeah.
Okay. Thank you. Sorry about this video thing. Maybe we'll play at the end better. Okay. The next sections, I think I'm going to just introduce you to different form of bridges. This is very common. It's a bridge cross section. You can see it's used the plank bridges, and these bridges you can span up to 18 meters. The thickness of the bridge vary from 240 to 700. It's short span bridges is we can use planks, but if you got a bit longer span, so can go up to 18 to 37. We use the, instead of plank, we use a deeper section called super T in here, but we can use eye girders and things. Yeah, this bridge in the length, it could be really long. It could be 600, 700 meter long bridges. Yeah, we used to design and build. Then this is what it looks like a super T bridge. In a bridge, you can see this the way it's transporting, and during the construction here. So one picture you can see on the top left-hand corner, I think the way it's erecting. Because I'm not going to spend too much of time on this, because we're going to discuss this one in detail, like at the in the later stage. Yeah, and this is the construction of those super T bridges. And the other bridges we use what we call the launch bridges. There are occasions that for example, if you has to build a bridge across a railway line or in a city that you can't stop the traffic. So in that case, we fabricate the bridge and we launch. I think one of the great example for the launch bridge that the bridge they built in France. I think you can see that one in video in it's available in the web. The way we build the bridge, and then after that we're going to launch that one across to the position we do. There are many elements involved. This one we are pushing the bridge, launch nodes and those systems. We're going to touch base with this one later on during the bridge design session. And the other one, this is not quite common in Asia, but quite common sometime in here. If the spans are larger, if the bridge's skews are big, and that sort of environment, we use what we call voided slab bridge. This is the massive chunk of concrete. It's really big. The bridges with maybe 15, 16, even bigger than that. Sometimes instead of having a box girders as a bridge, we replace with the voided slab. These are different form of bridges, but the applications and things we will discuss later how to design them. And then the voided slab bridge, it can be in the curved shapes, and it can be the void forms inside circular or any shape. The reason we are having these void forms to reduce the amount of concrete. Then when you reduce the amount of concrete, you're going to reduce the self-weight and the cost and the other issues related with the concrete. You're going to learn it. Then there are special type of bridges, like in here, the balanced cantilever bridges, the segmental box girder bridges. Yeah, this is one picture, the segmental box girder bridge construction you can see in here. Yeah, and then some bridges is the continuous post-tension span bridges. You can see this Cablestay Bridge in here, this bridge linking together. This very complex geometry, but two bridges, one going up, one go under. This geometry we can design and build. The main reason I put this picture in here, At the beginning, I said we designed the bridges kind of a 70-ton truck over there. But when we were building these bridges, these gantries, they were very heavy, because I was involved with all this bridge construction when I was at Bangkok. The gantry's height is 1,800. This gantry is very heavy. These all the temporary structures, they were very heavy. Yeah, you're going to put a heavier load during construction than during the service. Yeah, the bridge design is not depend on the design loads itself. It's play a significant a role during construction. There will be a significant cost difference. The plank bridge I show you at the beginning to a complex bridges like this, and then the Cablestay bridges, when you design and build them, the cost variation are significant. It's the cost factor is really big. It's really, there's a really big difference. You can't say it's 2 times, 3 times. It's depending on the project, depending on the bridge, depending on the environment you're going to build. So many factors into that one. Yeah. And the other one, the balanced cantilever bridge, the main reason I put this one, you can see this bridge, when we finished construction, is linked in together. This is a continuous span bridge. The middle span in this bridge is 227. This bridge I built when I was in Bangkok. During construction, this bridge cantilever is about 130 meters. And then the 115 meters, sorry. And then this cantilever. And if you look at, there's the small element in there, that's a bridge builder. Sometimes you would have seen this one, the construction in the bridge in over the Kalani River. And this the foam traveler is weight 100 ton, because this one we design and we fabricate and we assemble, we operate this one. Another bridges is the famous Sydney Harbour Bridge, and the suspension bridges and Cablestay bridges. All these bridges you design, you build, you need to have a special skills to do this one. Not everyone can design and build them. Yeah, you have to be a specialist contractors to do this work. To operate these foam travelers, you need to have a special operators with that experience, because all this mechanical and hydraulic system, we use this one to operate, moving in and out. Yeah, there are the special ways, but your fundamental is still the same, but you apply in a very different way when you're designing different bridges. They are not the same. Your modeling, your approach, your thinking, your analysis, the way you looked at, they are not standardized all the time. It's got a significant variation. That's what I try to. That's what I want to explain it to you. If you, these are real beauties. If you can be part of these projects, yeah, because these beautiful structures will be there to generations to come, and they will all appreciate, and they will all going to use it. Yeah. And another thing, if you want to be a bridge engineer, I want to put that one, you have to be very brave as well, because you are designing something. You are designing very thin concrete element. You will going to learn while you are designing bridges, and you are putting your bridge all element in your 17-inch screen, and then you are putting your knowledge and your analysis and design into A3 paper and person to build, and then you let 70-ton truck train to travel on that bridge. So it's not that simple. Yeah, it's not that simple. Then this is another bridge. I put this one on here. This is the Eiger bridges, quite common in Asia design. This is the steel bridges. This bridge actually I designed and we built in 1997. It's in Bangkok. And this is the part of this bridge in here, this Makasan bridge in there, and this Eiger bridges. This is quite common Eiger bridge construction. Yeah, because it's the cost and other thing, but there are so many factors we need to think when you get the bridge design form. It's depend on the cost of labor, cost of machineries, and the safety and so many aspects we need to look at. Therefore, you can't compare. That is what I want to tell. Someone build in one country this kind of a structure. We want to do the same in our country. No, you can't do that. You have to look at so many other factors related to that one. So therefore, the bridge design and selecting form of bridge is not straightforward. You have to think. You have to look at a lot of parameters, and you need to make your conclusions. And then pedestrian bridges. We be not only designed for bridges for serve the like a traffic, they drive cars, trucks. We build nice bridges for people to walk around. This is one of the nicest bridge recently they open up. Yeah, you can see the one in the middle. This bridge is located close to in my neighborhood. Yeah, these are the nicest pedestrian bridges. You can see they are beautiful. I think they were complex as well. You can see one on the top right-hand corner. Another thing you can see these structural forms they put. It's all different, right? They do the same purpose. Looks, spans, similar way, right? But they build, they put a lot of architecture and the aesthetics into those design, right? So while you are walking that one, you're going to enjoy it. So therefore, you need to appreciate that one, the role that the urban designers and architects they're going to play in our infrastructure design. And the other element, the retaining structures. When you were designing infrastructure, is scope, because when you're getting a highway from point A to B, unfortunately, I couldn't play that video. You should have seen most of the things I'm going to discuss in this slide. You go up in a hill, go down, and you had to cut you had to do excavation, you had to cut a lot of deep cuts and things, and you had to come up with so many different type of earth retaining systems to get this thing to work. They are not unique. And then the geotechnical engineers play a significant role in here, because it's not only you have to design this thing, it need to last, it need to sustain for the significant impact. For example, the especially landslide and other thing, and you have to design them. There are many types of retaining walls. I think they are quite common, everywhere. You use the L-shaped concrete retaining wall. You use the block wall, your different blocks, you piece it, put together and build. I think the world greatest and oldest retaining wall that Great Wall. They build putting the rock block pieces together, assemble them together. Yeah, and then yeah, that's Great Wall. And if you walk around in our plantation industry, so we have a retaining wall. They are very old. It's still functioning, right? So you have a different forms, but when we come to infrastructure, so when we were building this thing, we have a lot of limitations we have to work around. Because of that, engineers, the geotechnical engineers, structural engineers came together and they came up with different, one we call soil nail wall. This wall is a very simple one. We're starting in here, you excavate, and then you add a nail. You excavate, you add a nail. The final looks like, you can see on your bottom left-hand corner, that's the you got a piece of timber, you put it in your wall and you nail it. Exactly same principle they use it. All this nail, they combine together, putting a shotcrete. That shotcrete is exactly the same like that piece of timber you're going to place on in your wall. That's the exact same thing they're going to do. Then after that, geotechnical engineer do all this magic. They do stability check, and they check the fluctuation of the water table, and they see during excavation, during service, all this condition, how this monster is going to stand. Yeah, stand. They do all this magic, and they will say, this is the nail length I need to anchor this one to here, all these rows different length. When we were building this one, I'm going to talk about the durabilities. You can see it's a construction stage of a soil nail wall. Because what we're going to do in rock, in a soil, we're going to put a nail in there that is steel. If you just go there and drill the nail and leave it there with the grout or something, right? Over the years, it's going to get corroded, right? So then if it is corroded, it's a whole function, all the design assumption, design intent our geotechnical engineers had is going to work. All of a sudden, while you are driving, right, this wall, this is going to collapse. Because of that, this nail construction, to maintain, to manage the 100-year design life, to achieve that one, to the design life of the retaining wall, we have to build this one in a very special way. Yeah, we normally put this nail, we drill a hole in the soil. That's what they are doing it in here. And then we insert these corrugated PVC sheets, and then we insert our nail inside. Then we have 2 layers of grout to make sure that, because this corrugated sheet, the PVC, the pipe, sorry, not sheet, pardon, PVC pipe will protect this nail from the corrosion and other thing. But we need to ensure that, because there should be an interaction between the soil and the nail, that we need to achieve through the concrete. This is a very fascinating piece of work. Yeah, the soil nail wall. There are so many information available in the web, but don't worry, I will give you a lot of design material while we were proceeding with this the design sessions. Yeah, this is the construction of shotcrete wall. Another type of wall we use in, I think you heard about this one, you have seen now around the infrastructure we are building in Colombo. I think we call the reinforced soil wall, RSW wall, some others call mechanically stabilized retaining wall system, MSE, but a different name they got. It's very simple. The way we build this wall is, I will show you in the next. We're going to build up. This is not cut. This is a fill. We're going to build up a road surface. From what we need to have a road surface 5 meters up from the existing ground level. So then I want to build up. I don't have much space to put a batter there. Then I going to have a very small space. Then I'm going to go with soil nail, reinforced soil wall. This wall is developing. We got this facing panel in here. We place that one, and that one we put the piece of, you can see this steel straps. You can see this color because it's all galvanized. They attach to them. You can see in this drawing, these layers, roughly 1/2 meter spacing, 300 to 400, in general 1/2 meter. Place this and compact it. It's like a block. This is, you can see when you compact this picture, you can see that it's look like a solid concrete block. It's a rigid block. This element will be acting as a rigid block. I could remember this incident. I think there was a massive earthquake in one of the, a couple of years ago in South American countries. You could see the bridge and the structure had some issues, and it's damaged, it's cracked, but this, the abutment, this reinforced soil wall or MSC wall, that block stay the same. It's a massive earthquake. Yeah, when we check these densities, the density is quite close to the density of the concrete. Density of the concrete is 24 kilonewton per meter cube. When you tested this one, it's in the range of 22 to 24. Yeah, these are the crushed rock we crumble and make a massive solid block and build up our retaining wall. The advantage, you can make vertically upright in this one. You can put your traffic on the top, and the block, the man-made, this piece of retaining wall, it will sustain all the load is going to, during its service life. And these are the beauty, the outputs of this retaining wall, this soil reinforced soil walls. You can see this, some of them, they have some artistic impressions. You can see these colors, and they all blend with the arrangements, the designs, they all blend with the surrounding. Yeah. The other one is the culvert and arches, other structures you're going to come across with the when you are designing highway infrastructure. The arch we use as a bridge, yeah, arch bridges, but some arches we use to build the bridge fill above that one. And the similar way, we use the culvert for dual purpose. We can use the culvert on the top, we can get the traffic, but in the same time, we can use them as a drainage media. We can get the water from this side to the other side. So in addition to that, you can see on my top right-hand corner, that culvert we are using for different purpose. That culvert maybe we're going to use for animals, fauna crossing. Yeah, this is for koala to go through this culvert when we are working in some infrastructure we are building in a remote area. So we have to maintain we have to manage our wildlife in that area rather than destroy them. We blend them with our infrastructure. Yeah, that's the purpose of this one. And the other element involved in the highway infrastructure is a lot. Yeah, the barriers. You can see the sign structures. You can see the different type of barriers, guardrail, the wire rope barriers, and the concrete barriers. There are different type of, you can see in here, the sign structures, different sizes. And this one is quite small. This one is big. And then here, further down, you can see like this one is used for the gantries for operational purposes like speed cameras and all these things assembled in there. And yeah, it's in a modern highway infrastructure. We have lots of them incorporate in our modern the highway infrastructure. We have to lots of them in there because the way we need to locate them, they are very special. We're going to discuss them. In addition to that, we need to have a noise wall. I mentioned at the beginning, because when you are building a highway, you are putting a lot of traffic in there, you generate massive noise, but next to the highway, people is going to live. So you can't disturb their livelihood. So you need to do the noise analysis, and you need to make sure you are building structures with certain heights to reflect those noise back into the road and control that one. They were designed with the blend with the environment. You can see this one, the one in the middle. You can see only the steel element there. This is a see-through noise wall we put there. The main reason when you are driving on this picture on the left-hand side, it's a sea. People can, when they drive in through, they can see around. Yeah, and the other thing, we blend with the colors to match with that one. And there was a bit of architecture in here. You can see this shape of the noise wall, one in the bottom, one behind. You got plants in there. It's all blended together. Yeah, it's not a piece of concrete structure. It's not serving itself as a just a piece of concrete structure. It's to, yeah, a lot more than that. And then anti-throw crane, I think it's better in Sri Lanka also. We need to have that one. The main reason is here, you got a highway, people are driving in here, this thing, people drive, we have walkways, people walk, people ride bicycles. And then if someone, especially the teenagers in that years, because we all pass them in that way, they drink something and throw that one to the traffic in here. If it is hit someone who's driving 80 kilometers per hour, 100 kilometers per hour, that can create a massive accident. That is a big problem. So you need to find the way to mitigate that one. So we add throw screen in here, but you can't just add the piece of the wire mesh kind of mesh on here. You have to blend that one with the environment and your infrastructure. That's all add value to that one. You can see all these pictures is when you look, it's all look different. Yeah, it's all look different. Someone can ask, why can't we make this one easy way, just rectangle block, cut in standard piece, reduce the waste, and we go and fix them? It's not. So we do all those things. At the end of the day, what we need to understand, what we are going to build in here, the people is going to use for more than 100 years. Yeah, That's the whole purpose. That's what we're going to invest in here. The presentation is getting a bit longer. Yes, looks like 646. In here, that means it's close to 146 in Colombo, 246, I'm sorry. Yeah. And the other one is the fauna crossings. You can see the, while we are building infrastructure, we are building these elements for the animal to pass. We don't disturb their environment. We are disturbing, we are building our highways through those the areas, but still we try to blend them. We try to make their life, we let them to live not normal, but at least facilitates for them to have their usual habitat crossing from this end to other end. Because when you are building on a highway, no animal will go near that one because of the noise and the amount of traffic going in and out. If they try to cross the highway, yeah, they're going to definitely die. They can't. Yeah. And that is the first session of the presentation. Stuck for a while. Yeah. You only need a 1 or 2 minutes break, or shall I continue?
I guess it's okay to continue also. That's fine.
So, all right. So then the next section, I'm going to touch base with you very briefly. Maybe I will go in detail later on in the other session, durability. Durability is very important in not only bridge engineering, in any infrastructure design, I think you can understand now when you are in the university, you study a lot about concrete, the reinforcement material, so many things. Even in the university, we learn about chemistry, right? And in Sri Lanka, you have to do chemistry in your HSC to get into engineering studies. But we learn all those things to understand the durability and performance of the structure. It's play a significant role. The durability, first we define what we call the asset, all these elements in the bridge, column, girders, bearings, barriers, doors, crane, all those things you saw in previous pictures. All these assets, even the road pavement, road barriers, even sign structures, all this painting, even in the sign structure, we put a paint, that painting, all those elements have a design life. For example, if you get a sign structure, so paint, every day is exposed to the hot sun, right? Then the HV related issues is quite critical, the performance of that one, right? Then all these assets we identify, we define design lives. So then when after we build and hand over to the client need to maintain all these elements, like maintaining the university student with the kindergarten mixed together. That's if I give them in an example, you can understand the way. You got a different behaviors and different forms and everything, but very young age to very intelligent people, all this combined together in the same place. That's the way they need to manage. They need to understand it. They need to have a systems to do that one. We design life, we identify our assets, then identify the exposure environment. What is exposure environment? I will give you a classic example. You build something in Colombo, it's right behind the sea. You build something in Dambulla, that's middle of the country. You build something in Hambantota, that's 3 different areas. You got 3 different climatic zones, right? So then when you are concrete or steel or any element you expose to that environment, the behavior not exactly the same. You build the same bridge, but they're going to expose to different environment, they behave differently. This is the one area in engineering we need to improve. This is the one of the best areas in Australia. So this is the durability design is one of the best, and we go into depth in this design. And our durability engineers have spent hours and produced 400-500 pages of reports to tell to identify, to explain this one to the client and the other designers, we need to define this environment. And in that exposure environment, we need to design a deterioration mechanism when it's subjected to this one. For example, in the coastal environment, the salt, the water exposed to chloride attack. But when you go to the other environment, it's dry zones, it's exposed to different environment. And then we need to understand that one. Then if you identify this mechanism, then you can define the exposure classification. That's where the structural engineers come into play. Based on this exposure classification, this is how we streamline this design basically, and you define material, concrete, cover, and etc. Based on that, we define our performance requirement of the material. You will see in the next slides. And then we identify we detail them, we incorporate them into the design, and then we identify how to build them, how to detail them, how to incorporate them in the design and construction and maintenance and etc. This is the complex procedure. This is I put in a simple flow chart for you to get some idea how it's going to go. But we're going to spend some time to understand this one in detail. I will give you one example in next one. This is how the design life of a structure. If you design in a bridge, the main, as I mentioned at the beginning, we're designing a bridge for 100 years, your main bridge element, we design for 100 years. But if you go to your bearing, we design for 35 to 40 years. But if you go to protective coating, we have a 15-year design life. If you go to bearing surface, the asphalt in the bridge is 20. If you go to expansion joint and rubber and another thing, that is 40 years. If you go to your throw screen, you saw is 20 years. All those things, all these elements have a different design life. All right, why we important this different design life? For example, you build the bridge, you hand over to your client, right? And for example, if a design life of this protective coating is 15 years, then it's finished its design life. If client is not intervened properly, if not maintained during the design life, that's one thing. If you not replace or repaint that one after 15 years, that is not right. Then it's going to impact not only to that particular paint, it's going to impact the structures attached to that one, the steel plates and other things. Their design life is 40 years, then it's going to impact that one. So it's better to understand this each and every element in their interaction as well. So then it plays a significant role for designers to understand it's not only the bridge engineering, every engineering discipline, whatever the area you work, and especially if you are working in the water retaining kind of a structure, this is very important because you are dealing with water and all the time. If you are like designing sewers and other things, are more critical than the bridges. You need to have a better understanding how to protect them, and you need to have a method and procedure put in place to incorporate them in your design and in the maintenance stage. And these are the design lives. You can just read through them. Yeah, you can name it. All these elements, you can have a different design lives. In the exposure environments, I just briefly go through this. Of course, the air quality and the rainfall and the temperature, extremely temperature. For example, I can give you the classic temperatures. If you're going to see in the next slide, while we are building concrete element, like if you get a bridge footing, they were very thick, 1.5, 6 meter in length, 1.5 thick, 5 meter in width. When you pour this piece of concrete in there, that generates significant amount of heat inside during the hydration of the cement. You can't let that one to happen. If you let that one to happen, there is a significant the massive durability impact in this the performance of the structure during its service life. So the temperature control, the humidity control, of course, to the bridges and the concrete structures is subject to creep shrinkage. This play a vital role. And the soil exposure classification is very important. You can, underground, when you put a structure, especially our pile, you can't see that one. You can't see that. You just build it, right? Even during construction, if a board pile is filled with bentonite, you can't see most of the thing. When you are building it, if you do not know what is the underground behavior, what is the underground soil environment, what sort of material you encounter in this one, in these soils, it's got a chloride, it's got a sulfate, they were harmful to the concrete and reinforcement, then yeah, you have a lot of issues because your pile can't stand there for 100 years. Yeah, and then the groundwaters play an important environment, and the water in the creek, canal, and if it is in the exposed to tidal zones, those structures, yeah. And the deterioration mechanism is the acid sulfate attack and chloride induced, another called carbonation, DEF and AAR, and the cracking of concrete element. Another thing, stray current corrosion. I think this is mainly we have in the rail bridges. When we electrified the rail bridges, we have this issue, and early age thermal cracking with the large thickness of concrete members. We encounter these. We have this effect. These mechanisms need to understand. It's a wider range of engineering area. This durability engineers, they have a really massive understanding about all those things. They identify them. They advise you what sort of measures you need to put it into place while you are designing. In the same time, they advise the client how you're going to manage them during the maintenance stage as well. And the durability, the exposure environment and other classification according to their environment is defined in the design standards. This is some of the extract I got from the Australian standard. And these are, we specify in the performance requirement. For example, when you identify the exposure classification, they said if you define your concrete in a particular exposure environment, you need to have a minimum amount of concrete this much. You need to have a minimum amount of your water cement ratio, the maximum is this much. You can't change that one. There are so many performance parameters requirement. We put that one into place to get the best outcome. In other words, to achieve our design intent. And the other thing, another thing we maintain is the maximum shrinkage strain. If I give you a simple example for you to understand what is this exposure environment, classification in this one, B2, is where if you build anything in Colombo, its exposure environment is P2 because you are right in front of sea. That's a classic example. If you build someone in the middle of the country, like in Dambulla, you can go to exposure environment A. Yeah. And these two elements, if you design your concrete, and you can see the exposure environment and A and the B2, the amount of the cement you need to mix in your mix design. If you look at this table, the shrinkage allowances we put, and the exposure environment A, we can go to larger shrinkage, drying shrinkage, but if you go to B2 environment, it has to be reduced because if your concrete crack the surface crack, if you get the concrete element in Colombo, is more severe because it's exposed to the sea breeze. That's significant. Yeah, this is a very simple example I gave you because I don't have much time to go in depth all these slides, but you can read through just to understand this one. This is the summary we got here. The exposure classification B1, the concrete strength in the bridge element need to be 40 MPa. Your maximum cement ratio is 46, and your minimum cement contact is this one. You need to have the binders. You need to have a binders certain percentage. These are the fly ash minimum. You need to have a 5 to 30%. But if you go to exposure environment, you need to have mostly we go with the 50 MPa concrete, and you can see these binder percentage same, but the shrinkage constraints, they're getting different. But if you go to like if you just build something right in front of the sea, we have to design for exposure environment C. That is really very typical. I think especially achieve this shrinkage limit in real concrete is a very extreme, difficult task. And then this is the durability designers do, durability schedule they will give you. For example, in here, you got your pile, diameter 750, is exposure environment, is soil. We build middle of the soil. And this exposure classification is C, is really severe environment. And the minimum grade of the concrete you need to use 50 MPa. And you need to use this much of binders. Your maximum water cement ratio 40. And your minimum cement content is this. And your concrete cover is 110. And you need to do a special clearing to achieve this one. This thing, durability engineers give it to you. Then the structural engineers need to, when you design your concrete, you get your pile, bending moment and shear force. Because when you are designing, when you're placing your reinforcement, you can use software or you can use your spreadsheet, concrete cover play a vital role. 110 millimeter concrete cover, 750 diameter pile, that means diameter 750, 110 concrete is reduced to 750 minus 220 is 530, still good. Adding and subtracting, yes, still good. 530. You can put 16 millimeter diameter stirrups and 24 millimeter diameter bar. You can see your concrete core, how small it is, right? How small it is. Yeah, sometimes it's just good enough to put your trimmy pipe in there. Yeah, these are the things they summarize and they will give it to you. And then this thing we documented not only in our design reports and other thing, in the design drawing as well, because you need to use them in your analysis, and during construction, the contractor need to use these values. Yeah, I just put these slides for, if you read through, you will see they are different. They are different science, they are different. So then we can't just assume them blindly. Yeah, you can't just assume them blindly. You can't use, because we use in previous project that cover, because of that I'm going to use it here. That's not right. Yeah, that's not right. You can't do that one. If you do it, that is wrong. And I'm going to touch base next couple of slides quickly. The processes and QA QC system put it in place in the design and construction environment, mainly in design. And in here, what we going to first, I'm going to discuss safety in design. This is something that's very important for us to understand. As I mentioned in at the very beginning, please don't use any of this to compare what you are doing currently, what is the other part of the world, especially developed countries, is doing. The safety is one of the most important role, because we are building and designing and building highways for our communities to have a safe environment to drive from one place to another. That's the whole purpose. Then while we are building while we are maintaining it, we need to look after those people as well. They're very important as well. Then there's a massive role the designer also can play. To explain this flow chart, I will get you a classic example. This example is, let's say in Colombo, you got a shopping mall or you got a school, right? You have a road marking. Let's say this is for pedestrian to cross, right? Just mark there, pedestrian to cross, right? Now, pedestrian to cross, when you cross, who is going to cross? The people is crossing, kids and then teachers and students, and then anyone can cross cross the road. Then who else? People are driving the cars, right? Then the life cycle phase is, okay, this one, the life cycle phase is the design phase, the construction phase, maintenance phase, right? Demolition phase. These are the life cycle phase of a structure, right? Sorry, I didn't explain that one before. Then what is the hazard in here? Because while you are crossing, Sometimes people are talking to their friends, right? They just drive through that one. Then they hit a person, let's say the student, and he got injured, sometimes fatal. He may be died, or he may be get the permanent injuries. He may be the disabled rest of his life. So it could happen, right? What is the hazard in here, right? The hazard in here, if a careless driver hitting a student, right? While you are crossing this, right? While you are crossing, the person can hit. And the cause is the accident, and the consequence, right? Your car may be damaged. That's one thing. Your insurer, you have to deal with them. That's one consequence. Other one, that's more the student, he will get injured, right? That consequence, they have many different outcomes, Based on that outcome, you can make a risk score. You will see in the next slide how to do that, right? If it is a minor injury, right? If he just go close by, just stop the car and he just get shocked in there, he got a minor injury, just a small scratch on the body, or he broke his arm, but it still can be fixed, but he's permanently disabled. And if he's died, you can see these different outcome consequences are different. You got the likelihood. Yeah. You can never rule out the possibility that person is going to hit a kid there. It's possible, right? But maybe sometime, if you put so many restriction, if you put the other stuff, maybe likelihood may be less, but we can talk about that one later. Then we identify the control. What a control, okay, this identify the principal said, the prefects, you have to stand up from 6:30 to 8 o'clock in front of this, and you have to control the traffic. Don't let them to come near our student. Let them to cross the road, and tell the student, don't go one by one. You have to stay until you get the signal from the prefect, right? That is, the school principal can do things, right? Educate the kids, right? But the other thing, the road authorities, for them, right? It will be in the news, it will be in there, a lot of phone calls, a lot of people discuss about them, a lot of people blame them and criticize them. But for them, what they can do, they can put a traffic light there, right? They can put the traffic light there. If they put the traffic light, so that we can control the traffic, right? You can do that. Then after this, you can go through the same process, right? What happened? Even if you have a traffic light, there are a lot of incidents all over the world. People drive through red light, right? People drive through while people are crossing the road. It's happened everywhere in the world. Still there is a risk. But likelihood in these first instances is possible, but in this case, the likelihood is much less. If you got a traffic light, if there's an accident, I'm sure the people, the principal will put a fence across, having a two prefect on either side to make that likelihood never going to happen. But you can see the residual risk we reduce. But it still could happen, but likelihood is less. The outcome is better. Then you get the risk areas, and then you give it to risk owner. In this case, the risk owner is not the road development, the road authority, is more to with the principal. Then the road authority can call the principal, can say sir, we have already set up a traffic light in here. And then if you still think there is a risk, so yeah, you can ask your prefect to still on the watch while the kids are crossing the road. Sometimes kid may just cross the road without looking at the red or green or yellow in there. They might talking to their friends and they might cross the road. To avoid this situation, yeah, to manage that risk, you can do it. Then these are the action required. The risk owner is the principal, the action we can take. This is one of the simple example I give you. You can apply the same thing in the construction industry. It's quite common. Working in heights. Everywhere we do construction. Every construction we do, we work in height. If you fell down, consequences are, like I described below, is different. Because of that, we had to do risk assessment. We talk about this one in detail later, right? It's a simple thing. You got your give numbers, your consequences, insignificant, minor, moderate, serious, catastrophic, like I described before. Yeah, this event could happen. You can customize the way you want it. Yeah, this particular project, particular event, you can make this table the way you want. And extremely likely it could happen all the time. It's like rain, for example. Yeah, and very likely, unlikely is rarely it could happen. It's like a unlikely, rarely situation is where we put that traffic light in front of that crossing. And the likelihood, we got the road crossing, but still no traffic light, right? It may be a driver's fault, it may be the student fault, or the pedestrian faults. Yeah, it could be. You can generate this one. You can look at this risk profile. How are we going to manage this one? This is not only related to design itself, it's related to the insurance as well. Over the years, I think this is, I'm always telling, like over the years, I think the countries we are developing, the expectation of the people is getting higher, and the things is getting not easier, it's getting complicated. With, for example, with the technology, things getting easier, similar, in the same way it's getting complicated. And then the people expectation and demand will be different. These things play a very important role. So when you are designing a bridge, those infrastructure, any infrastructure, anything you design, you need to pay attention to this one. It's very important. That's what I spent some time in this slide. The other thing is the quality assurance we put in place in the designs that we call QA QC system. The way the quality assurance, I think my classic example is the water. You get the raw water, you made it to a drinkable water. That the water supply drainage board in Sri Lanka is doing. Every country, they have their own government agencies to manage that one, government or private agencies. I think they produce the water, but you trust me, they got a different quality. It's the same principle we're going to apply when we were designing our bridges or any infrastructure, for the sake, any designs we do. When we were designing, it's better to understand, not it's depend on the level of engineers, because if you are a very young engineer, you're working in doing all calculations and things, you are exposed to some things. And if you are a senior engineer, project manager, the way they exposed to certain things is different in the project. Everything, as I mentioned before, we are buying by a contract. The contract document is play a vital role. That is coming from the client. Client tell you what to do. It's listed, described in this document called project deed. And he tell you how to design his bridge. This is my requirement. This is what I want. This is what you have to design. You have to satisfy this thing. For example, in the scope of work and technical criteria SWTC, client will tell you, my bridge girders, I need 100-year design life without any maintenance, right? Right. Let's say about 20 or 34, 40 or 50 years later, so we all not designed that time, we all not there, but all this organization is there. If you are the design company, like the company I'm working is older than 100 years, the company is there, they are responsible for that particular clause because they haven't fulfilled that one. The client is not going to spend his money and fix everything. He will tell his lawyers, will say, no, that's what we asked, that's what they gave. So this is their responsibility, is to go back and fix it. Then after that, is go out beyond engineers' hands. It goes to the lawyers. They work on lines. They work on words because it's different to us. We work on models. We do calculation. It's different. So this SWTC, they define what they really need. And sometimes they give you a tender design, preliminary design. As I mentioned, this much of lane, I need this road. I want from this city to that city. I need couple of access to this road, that property, this temple, this church, this mosque. I need to this school. I want to make sure when you are driving this one, because these worship places, you should not manage, you should not disturb that one, because people just want to have a quiet time in that places, because just make sure everything is working. That's all documented in there. And then designers and contractors coming into the display. I think when they start designing, we don't dump everything to the client at once, because they are complex work. They're very complicated, very complex. Many people involved. They gradually build up. They gradually build up, like us or like a plant. It's gradually building up, and then we provide this process in different stages. We call preliminary design, tender design, concept design, the substantial detail design, then the 100% design, then design approved for construction. Yeah. We have so many layers in the process. We do. When we do those design, we say, I designed this one. My chief engineer, he got a 20 years experience in this design. He's capable of approving anything. His signature is good enough to build that one. No, you can't do that one. It's always good another person to third party to have a look, right? And I mentioned at the beginning, when we were designing, we have an interface with so many people. To make sure that everything is on board, we have to have a verification process. That verification process is starting at the beginning. Am I dealing with correctly with my own team? My road alignment designer, my road designer, right? My drainage designer, my urban designer. Am I interfacing with them? To do interdisciplinary review and make sure that all these things you incorporate, you capture. Not only you, everyone has to do this. Then before you send it out, your chief engineer, he will have a look and he will go through and say, oh, okay, it's all fine. I think I found these are the small things you need to change. I think certain stuff the client required defined in this SWTC is not going, you haven't matched this thing. You have to make sure that you cover that basis. So can you please go and review that one? That you are doing internally by yourself. You see, this the water purification thing I'm talking about. You are purifying your raw water you are getting from the client and to make it drinkable water. And then this is the client responsibility, is to appoint these people, independent verifiers and proof engineers, depend on the complexity of the project. This is in this section, the client need to pay for that. It's not the designers or contractor will pay, but paying for them, independent reviewers, they're going to look at whether this designer fulfill the client, the contractual obligations he agreed with. And his own experience in these designs is going to comment on your design. Then, when you get these comments, you have to change certain things. You can't go back to the independent verifier and say, no, I don't worry about your independent review because I designed, my chief engineer signed it, we are happy. No, we can't do it. You can't do that. Yeah, you have to look at what he's trying to point out, because the independent verifier has got a responsibility. It's not sending something. You need to add some value to the project because you are getting paid. You need to make sure this design, no loopholes. You fix them, you identify them, you point out to the designer and have a conversation with each other and resolve the issue, make the design better. When you get this thing done, you can see your design, right? Before you, while this one is sent to the client as well, it's looked at by many different people, many different engineers with different level of experience. you get a better outcome always. Yeah, I can give you one classic example. Suppose the drafting error, simple errors, you build your bridge. The pile cover supposed to be, normal cover in the concrete is 45 millimeters. But if you build in a soil, it has to increase by, the standard number is 30 millimeter, supposed to be 75 millimeter. If you're a young engineer, if you just put that one as a 45, because you did, before you design the pile, you design another column, you use the 45, it's in your mind, you put 45 in the drawing and everything is go. In contractor build that one with 45, but sometimes the foreman might scratch their head. They'll know this one 45, that is something wrong. Sometimes they ask from the client, they can do. Yeah, they can ask from the client. We will learn that one later. But suppose they build, they missed that, they build. At the end of the day, someone found this one, you build your bridge, you build your pile, and they found that supposed to be 75, you build 45, the design life of the pile will be much less than 100 years. How are you going to fix that one? This is a very simple thing, very simple, maybe a typo, maybe a very simple mistake a junior engineer do, doesn't matter. We can do mistake, we all do. Yeah, it's fine. But this is the whole idea of verification process, to identify all these nitty-gritty things and to make sure that all this design comply with the contractual requirement. One way for designer, verifying someone your design is helping a lot, because a lot of your contractual obligation, if you missed out, he will check that one, he will pick that one, he will let you know. Then at the end of the day, when you finish your design, when you present to the client, when the people build, it's a nice design, good design, it's buildable, is everybody happy, then you will get the credit, not the independent verifier or a proof engineer. Yeah. I will just want to put a very simple differentiation, who is independent verifier, reviewer, and the proof engineer. The independent verifier is the one who is going to check your design against the contractual requirement. He will find if there is a massive design deficiencies. The proof engineer is the person, what he's supposed to do. You give him a set of a drawing. This is your design. He just has to check that drawing against the contractual requirement defined in here, for example, against the design codes. And he need to tell, you design your girder, shear reinforcement, not enough. Your shear reinforcement spacing is higher. You design your pre-stressed concrete girder, your number of strand is okay, but during the stressing and during the transfer state, the girder is having issues, it's not comply with the code. So you need to point out, then you need to go back and check your design. You have to resolve that one. These two people have two different roles to play. And then we all the thing and we document all these elements and this verification process. We document them together. We put it in our design report. We will discuss them in detail later. And the design documentation, we develop design reports to capture everything. The design report is very intense, very important, sorry, beg your pardon. Because after 30, 40 years later, the people who design, those who build, nobody is there, but it's going to own by generations to come. The people will manage and maintain. But when they look at the drawing, there are drawing is there, even certain things you can see in the site, but you don't know what is the designer's intent, what he had in mind while he was designing it. Whether he complied with what is the client requirement back then, is about 30, 40 years ago we did. All this as-built drawing, all this document, if we read together, he can refresh his mind. He can go back to that era. He know that designer did this one. He assumed this thing and he went through these processes. If you want to go in depth, there are certain issues they identify while they were reviewing. It's all documented in this process. Therefore, these are the things. Now in our bridge, we got this issue. So we know that the origin of that one. We got a better understanding, and that's very important. Even design documentation is very important for client to maintain them for the design life of those infrastructure. And this is a very simple QA process. You gotta then the design, the concept design, the 15% design, the concept design, 15% is numbers, is what we call concrete outline. You got the shapes, cross section, the elevations, yeah, the plans, the basic concrete outline, because 3 pages, but it tells you a lot of things. The people can understand a lot about that one. You will go this one in detail when I'm discussing about the bridge drawing. I'm going in detail all this step. Then we got the 85% design called substantial, 70% now they call substantial detail design. Still design is in progress, but this one is good enough for contractors and things to they start their preliminary procurement work as well, or the client to get a better understanding. This is what we're going to present you at the end of the day. This is the final set of drawing looks like, but some drawing we're not going to include. We're going to do fine detail. We're going to include, for example, elevation. We have a reinforcement, but we are not detailed in a right way. And then we provide that one. That's helped the people to get a better understanding about what we are doing, what is or she going to get at the end of the day. When you go to 100% design, that's design is complete. Everything has to be there. Levels, elevation, detail, you have to go to review. If there's any issues, everything has to be closed at this stage. Nothing is there. You send that one client to have a look, and if he's happy, he can, client or his representative or IC, independent certifier, if they're happy, they can certify the package. Then that one we issue for construction. Even when you issue for this construction, while they were building it, we are going to change this one. Many changes you will see in the next couple of slides. Then you're going to see in your as-built drawing. Yeah. And we're going to incorporate them in the as-built drawing. Then, excuse me. Sorry, we're going to incorporate them in the as-built drawing. This drawing, our client is going to preserve, and we're going to use it during our maintenance and, excuse me, yeah, maintenance stage. Then the QA and QC design process, like I described before, this flow chart, your SWTC, your scope of the work, your design optioneering. We will go through this one later stage with value engineering workshops. Yeah. And then your initial design, preliminary design, interdisciplinary review. Then it's finished. Your internal reviewer, your senior engineer review that, your external reviewer review that one, and then you get the comments from them. You just address them, and you stage from 15% to 70% or 85%, and then you go back the same process. Yeah, it's exactly same like filtration of the water. You just keep going. In the 100% design, you got really the best quality water, best quality outcome. The reason I mentioned, we get raw water, we get drinking water, but different countries, we have a different standard. Still in engineering, we use same standard. In Sri Lanka, we are using a British standard, Euro code, but the design is still outcome we are going to get in Sri Lanka. And if you compare with the UK, they are not the same state, right? Because the different processes we are putting in place, different approaches we are going to do. But if you go through this process, you don't want to match, but you can get better. Yeah, these processes you need to appreciate. It's not challenging someone you do. You should not get offended if someone make a comment on your design. You need to get positively. You need to think positively. Yeah, he find out it's better, because rather than we are building something wrong up there, it's going to cost a lot of money, my company and the client, and it's better I use this one in the upfront, and then the next time when I'm doing my design, I will take extra care. These processes will help to improve ourselves, improve our productivity, improve our efficiency, and at the end of the day, we are developing the better quality designs. Yeah, that will help everybody. Yeah, even a client, you're going to save lots of money. That's why the client always need to spend some money. They were very reluctant and lazy to spend the money for IV and independent verification and proof engineering, but you should do that, because that will save you are one of your, if I give a simple example, the one simple claim contractor made during the construction process, if you miss something in your detailed design, if the contract is only the bill according to your drawing. Yeah, these are there are many examples. Yeah, I think everybody knows in the industry, you always came across this situation. It's quite common. Yeah. And then the quality assurance processes in the construction, contractors can't just go away. When they were going there, they abide by the deed, they have to abide by the construction specification, they have to develop method statement, they have to evaluate the risk environment in everyone. Then if we want to change something, if we think the designer missed something, he can't go straight away and build that one because he made a mistake, therefore I'm building that one. That is not my problem, his problem. No, not like that. Then they will ask you to change the design. Sometimes the construction method, if you develop some detail, he want to change that one. Then we can't, we don't want to do over the phone, because we need to have a documentation process, and that process we call RFI. And sometimes when they build, for example, you build the concrete, you cure that one because of the certain thing, because the concrete crack, and then it's not comply with your construction work specification, then you need to go and fix it. If your concrete crack, the client can go and ask, you go back and break your concrete and pour a new one. No, you can't do that one. Then the designer need to come up with the solution how to fix that one. Yeah, how to fix that crack, how to do this repair work, make sure that it's meet the performance requirement. Yeah, this is the bit of a flow chart in the RFI process. The contractor, he want to change something, he identifies something, he want to change something from the spec, then he generate RFI, submit to his team, and then they submit to the designer, they review, they send is acceptable or rejected, they say no, you can't change it, please follow the design. He will give the reason. You can't say simply no, because I'm a designer, you are a contractor, you build what I designed. No, you can't. You have to provide him, you have to give him reason. Why can't you accept this particular design because of this logical reason? If you change this one, these are the impact. Therefore, it's difficult to build, but still we have to construct this one. This is the way the professionals has to work. And then this construction RFI then incorporates changes into as-built drawing, because otherwise your 100%, your construction drawing issued for construction or approved for construction drawing, and what we build is not the same. Then you need to document that one in your drawing to make it work, WA drawing work as executed drawing or as built drawing, this drawing, and you need to document them. Like I said, 20, 30 years later, someone else read that one, he should be able to understand what's happening here. Then you RFI number and this reference to that one, you place your RFI somewhere, you save somewhere, and it's mentioned here. Then if some person 30, 40 years later, if you want to see that particular element, he can go and he can check that one. He can go and read that one. This is what all this process is all about. And this is the whole process. Some instances when you develop RFI, it has to send to IV and PE, because if it is the quite sensitive critical structures, designer can't himself take that decision. He has to get the opinion from the independent verifier and proving. This is the process. It's a very nice, very simple and open process. Every party is involved. We all try to achieve one goal: to produce the better design, to make a better quality construction. At the end of the day, we're going to hand over better structures to our client, and at the end of the day, client will, our community and our kids, our children, they're going to get benefits. When you are designing things, have this thing in your mind all the time. Have all this thing in mind, because sometimes you may have a disagreement with your superiors. He might come and say, no, I don't have a budget. I need to push that one across. I need that one quickly. In that case, try to work extra hours to make yourself satisfy what you are doing. Don't worry if you can't get engineers, won't get paid overtime, but self-satisfaction is important. You know what they built. Your name won't be there, but you know from your heart, your mind, your contribution, your effort you put there. That feeling is much. You can't put a value to that one. The NCR process is the same thing, similar to the RFI process. If they made the non-conformances, NCR mean non-conformance report. If they not build something is comply with the spec and the design, the contract requirement, they need to generate that one. They need to submit it to the client. Then client will ask the designer to review it, and he will give the remedial measures you need to incorporate. Please remember that when the contractor define this NCR, he need to tell the client and the designer next time the same problem is not going to happen. These are the measures I'm going to put in place in my construction to avoid the same problem happen again. Otherwise, you say, is crack happened is concrete, no worries, no problem. The designer gave me the solution. The other crack, okay, don't worry about it. We already did that one. The bridge number 1, okay, that crack solved like this. You can use it for bridge number 2. Is the same, is concrete. It's a bridge. No, you can't do that. You can't do that one, because that's where the client is going to evaluate your performance. We call KPI, key performance indicators. The client will say how many NCRs you have from the contractor side. From the designer side, how many RFIs you have. Your design is not good. That's why you have so many RFI. Contractor keep asking me question one after another. If you are giving me a good design, it won't happen. It won't cost me. It's a lot of delays. It's going to impact everyone. It's because when you start the construction project, it's like you open up a tap. That's the way you spend the budgets, the money you spend. It's a lot. You have to keep that one in mind. It's very different the way the design office and the construction side. So these are the things you need to keep this one in mind. This process is very important. Everyone has to play a vital role. And the contract documentation, as I mentioned here, is a lot. The deed, SWTC, specification, drawings, the policy documentation, manual. If you go to drawing, you have so many drawings. You could attend the drawings. The client has his standard drawing. He's got his concept designs drawing, detailed design drawing, substantial stage drawing in that stage, and construction drawing, as-built drawing, construction staging drawing. Of course, when we design, build bridges, we have a lot of temporary works, those drawing. And in addition to that, all those things in the drawing, in addition to that, as I mentioned, we document designers' design intent in a report. There are so many reports because we need so many branches in the design, so many stakeholders in this bridge design, so many parties in all this one, because a structural engineer cannot write a design about highway alignment. Highway alignment designer cannot write a report about road pavement. Road pavement designer cannot write a report about the traffic design and staging and the road furnitures. Road furnitures, I didn't put that word, but I didn't mention the road furnitures is anything on the road, like in your house, you got furniture. Road furnitures is barriers, signs, structures, and all this, the all other element we are putting along the road corridor, we call furnitures. Even your, sometimes the drainage, the grades and things. Then the drainage hydrology design assumption they made, this design, the intent, the cover calculation he did, all this. the environmental noise vibration, the durability is part of vital role. In addition to that one, urban designer, he need to fulfill a lot of requirement, the heritage requirement, the community requirement, the client give him this requirement you need to fulfill. Then geotechnical engineer, he play a massive role in this one. We have to develop all these reports. For bridges, you have to report every bridge. They are different one bridge to other one. You have to generate individual reports, not for the whole project, one report. I got a one report and the bridge A, this one, bridge B, this one, no. Because there are requirements, the way the people review, there are comments, number of drawings you need to put, the issues you identify, they are different from one bridge to another one, retaining wall, traffic staging, temporary work, maintenance work. Then you have to develop reporting for maintenance manual and so many things. This is the reference document. Most of the thing I talk about, if you click this element, you will find those elements freely available in the Transport New South Wales website in Australia. There are the very good, very informative information. So a lot of information is available. Especially the client, I think it's better to have them. You can see the way it's organized, and even the designers to see a lot of specifications are available. Even you work, because this information value have got a lot of value. The way they manage this thing, they get a better outcome, better quality in the final product. I think this is the end of my presentation. I got almost 45 minutes or 30 minutes longer than the presentation I expected, because I thought explaining to give you a better picture rather than making the pushing really hard, like slipping the thing. I try to give overall picture for you to understand. When you design bridge, when you design infrastructure highway, what is that global picture? What in that jigsaw? These are the elements. If you're going to assemble these jigsaws together, you're going to get the nice picture. That's in your jigsaw puzzle box. Yeah. Any questions? Any comments?
Thank you, Mr. Rohit, for interesting presentation. I have a few questions. One is, now you all are designing bridges and now for 120 years. So during that time, the codes change and also the vehicle loads change. So how do you all, whether there are any reassessment during like 50 years, 100 years with respect to the stability and the strength of the building, the bridge?
Yeah, that's the first thing, Shirumal, you are my good friend, and anybody in the audience, please don't call me Mr. Rohit, just call me Rohit. Yeah, and it's a really good question. The first thing, when I was in Bangkok, I used the AASHTO standard to design, which is SH 2044 loading. The weight of the truck is 20 tons. When I decided to move to Sydney, to SMAC office as a principal bridge designer, first thing I asked, please send me the design Australian standard AS5100 Part 2 design loads. When I look at the design load in Australian standard, the Part 2, they got a design load SM1600. If I say with numbers, this is 160 ton vehicle against 20 ton vehicle I designed in the Bangkok, right? And the first thing is came to my mind, what is the member sizes in the member sizes in the bridges in Australia? That's the first thing came to my mind. Like over the years, the code has changed the loads. For example, the AASHTO, we use SH 2044 loading, but when we were at Bangkok, we tested the bridge. I tested bridge about, let's say, more than 10. Yeah, tested the bridge. We wrote a paper about the bridge analysis with our actual results. We tested for 32.4 ton truck train, those bridges, and it's worked. We tested, we checked the stresses, and we do so many things. Your question is, it's true. Over the years, the code is changing, and then the loading will be changed. But I think there are two categories of bridges we need to identify. For example, there are the bridges we built, let's say 30, 40 years ago. The material technology, for example, the concrete, we hand mix and we pour, and the maximum concrete is strength 25 MPa. It's a really big challenge. We design and build those structures, and we design and build for light loads. And when we come to today, we allow for the 70-ton truck on those loads. Bridges, still they are functioning. Still they are functioning. The way we link together this one in here, I think the road asset owners. Can you hear me? Hello.
Yes, we can hear you now.
Yeah, sorry. Yeah, they need to keep an eye on these structures. The one way, I think there are the bridge testing method. For example, in here the client wrote Transport New South Wales. Now they invent. I think the credit goes to one of our engineer, Vijay Ari. I think he was one of the pioneers to develop that system to test bridges and say it's going to work. Another thing, the client is always engaged with the designers to do the load rating, to the assessment of the bridge, and to refurbish the bridge. We do. But the current standard, I think they looked at this one in detail, and now they want to design these bridges for the larger loadings, like SM 1600 is quite a 160 ton, and we're going to discuss this one in detail. They're going to design for the larger loading to make sure that it's meet the future demand. In the same time, you design for the heavy loading, but they have a load limit in your vehicle. The one I put at the beginning in my presentation, the load limit is 70 ton. So these are the measures they put it in place, but this need to be updated all the time over the years. When we come to the design course, with my experience, I think I didn't have opportunity to work, but I think if you should have met some very senior engineers that maybe now they already retired. They used to design the a concrete element even using the serviceability limit says analysis back then. I got opportunity when I was in Bangkok. I designed all the steel structures using serviceability limit state analysis, and then 1994 the codes changed as to ultimate limit state analysis. So like in Europe and Australia, of course, they use ultimate limit state analysis. These design philosophies, they gradually change, and then Another thing that when we design a bridge, with my experience and testing, they have a significantly large the capacity, the excess capacity in the structure itself when it's performing together, because it's not that we are telling we are the over designing thing, because we are not using I think in some states, they like in California sometimes they use what they call their California truck train in their modeling. Some special occasions that people use, but your load modeling current code use is quite conservative, because another thing I think they do a lot of probabilistic analysis, modeling, research into it. If I give you, for example, we use the truck loading in the model in modeling the bridges to simulate the actual truck on the bridge, and that load we magnify by almost 35% to include the dynamic effect, the bridge and the truck interaction, that dynamic effect, we put 35% increase. And then that load, we increase by another 80%, we call load factor 1.8, to make sure that so the design, that load is not going to exceed. The probability of accident is much less. It's less than 5%. Even some client, they go back to the design standard. That's what I said. There's a significant difference in there's not significant. There's a difference between the codes we use for building designs against the bridge designs. They, again, some material factors they change to capture those things. Yeah, that is how in overall they have that approach. Did I answer you?
Yeah, yes. Thank you very much, Rohita. May I ask another question?
Yeah, of course, yeah.
I think we both come from same town, Cablestay.
Yeah.
And those days, we had a very nice bridge across the river, steel bridge.
Yeah.
And they replaced with a concrete bridge.
Yeah.
I still wonder why they replaced it, because they should have retrofitted or done something with that bridge, because it's, for me, I mean, it was a good bridge.
Yeah, I think it may be the fatigue analysis, but this is the classic example. I think that's the way we looked at. I think the road authorities, please bear with me, because sometimes maybe that time the people got a short-sighted decision. I remember that I was a second-year student. I think we were training at the Kalutara Highway engineering office, but I was really keen to go and see how they're building this, constructing this bridge. The Skanska, the contractor back then, they built that bridge. And the classic example is I think the Brooklyn Bridge in New York is older than 200 years. I think that bridge designed by father, is built by his son, they built more than 60 years. That bridge, 200 years old, still is functioning. Yeah. So we should have preserved that bridge, actually. Rather than coming up totally different design. I think that's what I said. If an architect and urban designer get involved in that bridge design, I'm 100% sure he will have a massive resistance to the what built and back then. Yeah.
Thank you.
Any questions? Dilina, you should ask a question, because you all are young engineers. I think you'll need to have some question. Yeah.
Your presentation has been very clear and precise. I'm not sure what to ask.
Then at least one. Yeah.
Yeah, I have one question.
Yeah.
Yeah, regarding this durability concerns that you stress that in which designs that you have to do much on the climatic conditions and the environment, etc.
Yeah.
So in buildings, we generally do go for the code reference, and as per you showed that the table of selecting concrete grade and cover and things like that. But
Yeah.
when it comes to bridge, it is of course 100 years and more. So, what kind of a special studies indicatively you do for that kind of whether you have some climatic condition over the period of time of the past period that gathered through, or some kind of additional studies rather than sticking to code? Yeah.
Yes, we do a lot of testing. Yeah. Especially we do lots of testing about, for example, underground one, and the exposure environment, for example, as I mentioned, close to the Colombo, the exposed to sea, and the other places. The other thing, like when we were designing buildings, the difference is when you, for example, if you design a column in a building, so you always have the tile or some architectural feature attached to that one. I think that will be that provides you a protection. Yeah. And but still, when you design, especially the foundations structures and the retaining structures in the building, I think you have to pay attention, because, for example, if you go to car park, for example, in a building, or you file, I think the soil condition underground, you have to be, because especially I think in the Colombo area, you have a really low groundwater in there. And I think this contamination of the groundwater is quite significant, because it's got a significant impact here. But you can do a lot of testing to understand them, identify to evaluate them, and they all, there are a lot of our durability engineers. They work with a lot of the read a lot of not only this the code requirement. I think they do most of their work through reading through the literatures and things. Yeah, maybe later on, maybe I can share a lot of. I have a really big resource full of bridge engineering and so many things. Yeah, because in my early ages, when I was your age, I used to design buildings when I was at Bangkok, when I started my career. Yeah, and then I can share with those. And this is the whole idea of this presentation series. I just want to, whatever the experience I gain with all of you. Yeah, the question you asked is really good, but when you come to the main structures, like you have architectural features in there, but especially the basement areas, I think the car parks and other thing, you have to pay a special attention, especially the foundations here.
Yeah, exactly. For the buildings.
Yeah, but I think the according to the, for example, see, like in Singapore, they had a like this is maybe not 100% correct, but they build their buildings for certain. They have a certain age, like 30, 40, or 50 years, and after that they demolish that one. They build a new structure in there. I think rather than maintaining them, but I think the especially in Sri Lanka, the amount of money we are putting for our infrastructure construction is significantly large. And then yes, it's better to educate the client. I think that is important thing, because we need to educate our client to understand that, and they need to get that one on board, and they need to contribute to that one. Yeah, at the end of the day, we get a better outcome. Yeah. Did I answer your question?
Yeah, thank you.
I have two questions actually. Can you hear me?
Who's speaking?
I'm Johan. Can you hear me?
Yeah, I can hear you.
Yes, I have two questions.
Yeah.
The first one, now it's a Sri Lankan contest also. We are transferring to the Euro codes, transferring state.
Yeah.
I want to know did you have done any comparison with Euro codes Australian codes. The first one. And second question, we discuss about the retrofitting for bridges, I mean structures. Actually there are any method, I mean any maintenance manual you are using, and how often you are using for that maintenance for, I mean, maybe the acidic attack and alkali attack can be happen for retrofitting. So the maintenance I think is very crucial. Then, how often you are doing the things, and that way I want to know.
You are Sohan, right?
I'm Johan.
Johan. Oh, sorry, Johan. I think the first one, to answer your questions, the first one actually I didn't do comparison in the Eurocode and Australian standard, but for the Sri Lankan context, I think we use British standard, the ultimate limit state principles. I think the Eurocode doesn't have a significant difference, because I use Eurocode, especially in the fire engineering one. But for the Sri Lankan context, whatever the code we're going to use, we have to change it. Yeah, I think for example, if need any help, I would like to be a volunteer and help, because we need to write to our the conditions. Even we need to look at the loading, the loading defined in the Eurocode. I'm going to discuss this one. I had to study a bit about Eurocode when I'm going to do my discussion on the presentation on the bridge loading. We need to have we need to study that one in depth, and we need to translate that one the way it's required for us. Because the design principles and everything, I think we can use sometime the certain loading, but we need to understand our context. For example, if I give you the barrier designs, because if you drive around in our highways, we provide the guardrails, but in front of a column we don't provide guardrails. We need to do a risk assessment. We need to come up with the permanent structure we had to design to absorb any the traffic impact. This thing we need to look at that one. We need to identify which area we need to change. We need to amend to suit to our environment. My understanding, I think Professor Priyan Dias from University of Moratuwa is my teacher is my lecturer in concrete design. I learned ABCD about concrete design from me. I think he has been doing a lot of research regarding this, the use of concrete to meet the Sri Lankan environment. I think all those elements, all this research, I think many other faculties in our universities, they are extensively involved in this research. Those data we need to collect, and we need to codify for our engineers to use. For the second question, because I'm heavily involved in structural engineering, but the durability is one of my interests, because when I was at the SMAC, we basically developed the durability team, and they are my good friends. We together, and as a verifier, I had to read those documents. I got a extra interest about this thing. I read all this document and know a lot of information I collected. The durability engineers basically do assessment. In addition to that, we do load rating assessment, what we call any structure. Depending on the age, that bridge we can model. We can assess for any particular loading system, what is the current condition, is performance, how is performed. For, let's say it's designed 30 years ago for a certain load, but you want to increase the load on this bridge. For example, let's say we designed that bridge for the the 2-axle the 6-wheel truck, but we want to put a 10-wheeler one, heavy one, like a 30-40 ton one. So then we want to assess that one. We can assess the bridge, and then the structural engineers, they do what they call load rating assessment. They link all code and new code together, and we can assess that, and they can give a load rating assessment whether this bridge has a strength to take that one. If not, I think now, like FRP, the solutions, I think a lot of solutions are available for bridges and culverts and other structures to retrofit. I think now technology is available. I think it's they're not as expensive as before. I think with minor changes, we can increase the strength of the structures. For your part of your question about the design maintenance manual, they actually, I'm not involved in that one. Is mainly managed by the clients, the road authorities, and then at the design stage, because we define the design life, we know with the discussion, learning from them, we know there are inspection routines and the maintenance routine they explain, and then we have that one in our mind when we were designing the bridges. I'm not sure whether I answer your question correctly, but yeah, this is the best I can explain it to you right now. But if you need more, you can send me an email, or we can have a separate discussion as well. At least if I give you some insight to your question. Or...
Yeah, maybe. Thank you very much.
Thank you. Any more questions?
Yeah, I have a comment, Rohita. I am Ravindra here from Sydney.
Oh,
yeah,
Ravi, how are you?
Good. Now I can say that. Yeah, I am from Transport New South Wales, by the way. Okay,
yeah.
So
the guys,
yeah,
if you need any information, things, you can
yeah.
contact Ravi. Yeah, Ravi.
No. No. I myself,
Yes.
I have designed a bridge, by the way.
That's
I
great.
designed
You're
early
a pavement
in my
specialist.
Yeah, I designed the bridge on my structure design. Charter design was Logalloy spillway, and
Okay.
Logalloy spillway, on top of the Logalloy spillway, we had a bridge. I mean, we had to put a bridge, so I designed that bridge as well with the spillway. So it's standing, its structure is so beautiful. I see so many Instagram photos these days, and as you said, I never believed that it will end up looking beautiful, right? And yeah, just a comment on your presentation. It's very informative, and I can tackle bridge designs. I grew my confidence by listening to this lecture. All right. Yeah, I look forward to the next session whenever it is. Okay. Thank you very much. Yeah.
Thanks, Ravi. Thank you
that's all
so
I
much,
do.
guys.
Okay.
Ravi is a specialist. He got his PhD in pavement design. If you guys have any question related to that one, yeah, just you can send me an email. I can forward it to him. Yeah. Or else I think he's available in
Thank you.
LinkedIn.
That plugin. I never wanted that. Okay. Bye. Good night. Okay.
Thank you, Ravi. Any questions? Any comments? Or
so if you have enough time, there's a question in the chat from Malik Milanta.
yes,
Shall I?
Yeah, yes, please. Yeah, you can.
He's asking to please give a brief differentiation on conceptual design and preliminary design of the bridges.
The conceptual design, the preliminary design, we call the substantial. The conceptual design, in the sense we present to the client like what is the bridge. For example, let's say we are building a bridge across the creek. So we're going to give them the what is the span of the bridge, because if there is a creek, there is a flood. And with our initial estimate, this is the bridge soffit level, and this is our flood level, 1 in 100-year flood and 1 in 2,000-year flood. But the initial stage, these are very preliminary, they are rough numbers. This bridge is, the span is this much, the height is this much, the embankment attached to that one, looks like, and you need a 4-lane bridge, inbound and outbound. So we provide the cross section showing that elements, and in addition to that, we show the other element, other road furnitures like barriers and the railings and all these elements attached to that. And in addition to that, we say for this particular bridge, if it is a 20-meter span bridge, we use the 1 meter deep super T, let's say 20 meter span, 1 meter deep super T. That's the conceptual design. And then that 2 pages, that's elevation plan and the section. It's include a lot of information. You will see this one in that session when I discuss about the drawing.
Hello. Can you hear me? Hello. Rohita, can you hear us?
Yes, Shiromal, I can hear you. I'm Ravindra here. I'm from Sydney.
Hi, Ravindra.
Yeah.
But Rohita got cut off, no?
Yeah, I don't know. It kind of freezed and then.
He is muted actually. Chatumi, can you unmute him, please?
Yeah, sorry. I don't know. I got cut off automatically. I'm really sorry.
Okay.
Yeah.
I think
can you hear me now?
We can end the session. Rohit, I will give with my official vote of thanks. And thank you very much, Rohita, for giving a very insightful introduction to the bridge. And this is not the final. This is one of the 8 lectures that he willing to conduct. Actually, he called me and told me that because we used to, we were actually in the same village, Nagoda Kalutara. So I used to actually learn applied mathematics from him. So that is how I knew him. And we met again at the university. He was at the 4th year when I was at the 1st year. So it's after a long time, I had the chance to talk to him, and he said, why not? I know he has done a lot of bridges, and then he was working in Thailand, and then again we went to Sydney. So I knew he has a lot of experience, and I know by experience that he's a good teacher and also good presenter. So I thought when he said that he can give a series of lectures, I thought this is a good time to capture him and give distribute his knowledge to not only to my company but also the entire engineering fraternity. So I gave the task to Dilina. Dilina did a wonderful job by connecting all the groups, CCB, CC, RDA, social structure engineers, and all the universities. So we try to, and now we have this YouTube channel also going, and always Sri Lankan engineers can watch these YouTube video and enhance their knowledge. Very important messages are given by Engineer Rohita with respect to the total system, the process of engineering, which is focused on bridges, but it is applied to all engineering aspects. And it was a good insight to all engineers, especially to the young engineers. who are embarking on their careers. So thank you very much on behalf of the Sri Lankan engineering community, and also on behalf of our office crowd. And it was a great honor to have you in this educational marathon, and hope to see you in the next 7 weeks. And it's a great honor and privilege to listen to you, and also it's a great service to the Sri Lankan engineering community. Thank you very much, Rohit.
Thank you, Shiroma. Because so I think you did the hard bit. I think organizing this one, especially Dilina, while he was doing his surgery, and even everything organized, even how efficient. Like on yesterday, to discuss about YouTube telecast and everything you all arrange, and another thing you all connected all the engineering community within Sri Lanka, and then to help this one. I think I'm really thankful to you, and I'm really happy that you initiate this, and then we were able to do something really good. I think that's the whole purpose. Yeah. And another thing, I'm really proud of you, because you are managing and training more than 130-140 engineers in Sri Lanka and designing marvelous structures. I think we really proud of you, and all of you, because all of you are doing marvelous jobs in the country, having a lot of issues to deal with day to day. And yeah, so but unfortunately we away from the country, but this is at least the best we can do to the country. But thank you so much to helping us to do this presentation. Thank you so much. Yeah.
We are proud of you also. Very proud. Thank you.
Thank you, everyone. Have a good night. Enjoy your weekend. Thank you.
Thank you, everybody, for joining.
Thank you.
Thank you.